Hi, this is Mr. Mayo, and I'm going to go over some of the problems that a lot of you had on the homework. So we're going to be looking at 25 through 28, and then after I do these, I'll show you 45 and through 46. I think the main issue with these is that you're not looking at what's on the axis. So I'll show you what I mean. This is saying the position is given in times 1,000 meters. So this is not 1, this is 1,000. This is not 2, this is 2,000. This is not 3, 3,000. And you're going to have a different graph than this on your homework, but it should look very similar. So when we're estimating the position, remember to find displacement, we just need the current position minus some initial position. So we want to know the position at 10 minutes and at 20. So at 20 minutes we can come in, we don't have to be perfect, we estimate that's probably about 3,600 meters. So it's a little bit above halfway. And then here, I'm going to estimate that's probably about 2,900, maybe 2,800, so we'll say 2,800. And you don't have to be perfect. UT has some tolerance, so be a little bit off. So we're going to do 3,600 minus 2,800, and that gives us a displacement of about 800 meters. Now you're going to have different numbers, but that's the basic setup. So we read the next option. The next question. It says, for the same time interval, find the runner's average velocity. Did you notice that is in meters per second? So what we're given is 800 meters. That happens in an interval of 10 minutes. But you have to convert that minutes to seconds, so there is 60 seconds in 1 minute. So multiply this out, that'll be 800 times 1 divided by 10 times 60, which is 800 divided by 600. So what would that be? It'd be about 1 point. I cannot do math. That would be about 1.33 repeating meters per second. So that was, I imagine, the issue for most of you is that you didn't notice that was seconds and that the intervals here are given in minutes. So the total displacement, pretty easy. Total displacement is from 0 to 30 minutes. So for this graph, it looks like it goes to about 4,800. So I'll say that, again, requires you to look at this times 1,000 on the axis and find the average velocity. Same issue. We're going to do 4,800 divided by what's now 30 minutes. Times 1 minute and 60 seconds. Multiply that out, so that's 4,800 divided by 1,800. I'm not going to do that, but you can do that in your calculator. Okay, so the main thing is you have to know to multiply the positions by 1,000, and if it's asking for meters per second, you're finding velocities in meters per minute, and that requires you to convert. So we're going to move on to the next problems, 45 and 46. Again, I think there's just confusion, not so much with how to do these types of problems, but how to read this axis here and here. Okay, so it says, given the initial position of 12 meters, what is the velocity at 4 seconds? Well, this first part really isn't pertinent to the problem. We can actually get this just from the graph itself. Now, if it's asking for 4 seconds, this is a tricky part. It's not asking for the velocity at this tick mark. Not that it matters for this graph because it's the same at every tick mark. But it's not asking for the velocity at this fourth tick mark. Because each tick mark means 2 seconds, this would be 2 seconds here. This next one would be 4 seconds. So it's actually asking for what's the velocity at right here. This is 4 seconds because each tick mark is 2 seconds. So you read that, and the velocity is not 4 meters per second because, again, each tick mark on this axis is 7 meters per second. So this would be 7 meters per second, 14 meters per second, 21 meters per second. So the velocity here is 28 meters per second. And again, you're going to have different numbers, but same idea. What is the initial position? The initial position is 12 meters. What is the position at 4 seconds? Okay. So I have another video on this of how to find position from a velocity versus time graph, but right here, remember, this is our 4 second mark because each tick mark is 2 seconds. So we can come in here. Remember, the area underneath this curve is going to give us displacement. So you can think about it in your head. I mean, doing all these graphs is not super important. If you just say, hey, I'm going at 28 meters per second for 4 seconds, how far have I traveled? Well, 4 seconds times 28 meters per second. That's 12. Oh, no. Let's see if I can do math today. 112 meters. Okay. Now, I mean, you can. That's just me thinking about it, but you can find it from this graph. The length of this side is again going to be 28 meters per second. The length of this side is 4 seconds. So when I say area under the curve, it's just saying multiply those two numbers. So 112 meters. Now remember, a velocity versus time graph does not give you position. It gives you displacement. It tells you how far you've traveled. So we have to take into account this initial position and say, okay, I was already at 12 meters. Then I traveled an additional 112 meters. So now I'm at 124 meters. And that would be our final answer. Okay, so again, I imagine the issue is these things here, but it's just saying for this axis, each tick mark is 7 meters per second. You can go ahead and even relabel them as, 7, 14, if that helps you. And each tick mark here is 2 seconds, so again, if it's super confusing for you, just relabel them 2, 4, 6, 8, so on. Alright, hopefully that answered your question. If that does not clear it up, just email me and I will give you a more detailed explanation. Okay, thank you.